Welcome back to freehighschooleducation.com. Today we are going to do chapter 5.7, Inequalities with Absolute Value, page 192. We are going to start with an easy example. Absolute x more than 5. Here, the definition of absolute value is the distance away from 0. So let's see on the number line the numbers that fit this inequality. Here we are saying that the distance of x away from 0 is more than 5 units, and that will be in this region or in this region. Here, even though the numbers are negative, yet when they go inside the absolute, they come out as positive numbers. So if we have a number here of -7, you put it in the absolute, comes out as +7, and that will be more than 5. So basically, we can rewrite this inequality as such, or x more than -5. So the solution for this inequality is this disjunction. Now we have another case where x is less than 5. In order to get the solution for this, we have to draw the number line again and apply the definition of absolute value. Here, the distance of x away from 0 is less than 5, and that will be in this region. And in this case, x is between -5 and 5. And this we can rewrite in this form, x more than -5 and x less than 5. When we solve this, these two inequalities, we have to get the overlapping region or overlapping set of numbers, and that would be the solution. In this case, it is obvious that the overlapping set of numbers would be this. If we graph this one, it will be this way, and if we graph this one, it's going to be this way, and the overlapping region is this one. That's very obvious in this case because this is an easy example, and we have seen that the solution is this from the beginning. But when we do more complex exercises, that is not going to be obvious. So in this case, where we have more than, less than, this translates into a conjunction, and we have to solve both inequalities to get the final solution for this inequality. So let's take another example. Here, to see the solution set, we go back again to the definition of absolute value. And in this case, our number is 2x minus 4. And the region where 2x minus 4 will be more than 6 units away from 0 will be this one, or here. Now, if we want to get the allowed values for x, we have to solve the inequalities of 2x minus 4 less than -6, this inequality, and this one, 2x minus 4 more than 6. And these two are tied up by the word or, so this is a disjunction. Here we get 2x is less than -2, and x less than -1. Here we get 2x more than 10, and x more than 5. So let's put these two inequalities, less than -1 and x more than 5. Now we draw the number line. And x should be less than -1, and x should be more than 5. And here we have the word or. So any of these two sets will fit this inequality. And this region between -1 and 5 is the rejected region. If you try 0 here, you get 0 minus 4. Is it more than 6? That's false. So this is the rejected region. And if you try here a -10, which is an easy value, you get -20 and -4. Is it more than 6? That's true. It is more than 6. And if you try 10, you get 20 minus 4, and that's 16, and that's more than 6. So here we check the two regions, and values from these regions fit this inequality, and in between does not. So we check our work, and our work is correct. Now we have a second situation, and that's 2x minus 4 less than 6. Here our number is less than 6 units away from 0, and that will be in this region. So we can say that our number lies between -6 and 6. This will be transferred, or we can write two inequalities out of this, and that will be 2x minus 4 more than -6, and here 2x minus 4 less than 6. And these two inequalities are tied up by the word and, so this is a conjunction. So let's solve this. 2x is more than -2, and x is more than -1. This is our first inequality, x more than -1. In the second instance, 2x is less than 10. We take 4 to the other side, and x is less than 5. So here x is less than 5. Now these are two inequalities that are going to give us the solution to this inequality. And these are tied up by the word and, the conjunction, 0, -1, 5. We plot the first one, circle here, and that's more than -1. We plot the second one, or graph it, and that will be this graph. And the overlapping region is between -1 and 5. So x is between -1 and 5. And that's the solution to this inequality. If you try now 0, you'll find that 0 gives a true statement. And if you try -10 or 10, you'll find that these two values give a false statement. And with this, we come to the end of this session. We hope to see you again.